Just before we embark on our class today, I want us to have a small recap on what we did last time. Who can remind us of what we did? We are covering differentiation. The topic is still differentiation. And I remember last time we were doing standard differentiation, where when you have been given a function of y is equals to ax power n, and then you are required to differentiate such like a function. So symbol differentiating means we are reducing the powers, right?
Yes.
We find dy dx, like in this, for instance, we have two unknowns y and x. Here we can say y varies either directly or indirectly with x. When you are differentiating such a function, we are finding dy with respect to this x unknown. It will be, we are differentiating means we are reducing the powers. We drop this n to be n x n minus 1. This is differentiation. And we did some example, like just a recap. When you are given y is equals to 2x squared, then you are required to differentiate such like a function. Who can remember how do you differentiate such using this standard differentiation formula? Yes?
dy dx.
Yes, dy dx
It is equals to 4x.
is equals to
4x.
4x.
Yes.
Is this okay? Yeah, it's right.
Yes.
We are reducing this power, which is our 2. Our n is 2. We drop these 2 to be 4, then 2 minus 1 will be 1. Thus we will have dy dx is equals to 4x. This is okay. Now today, I want us to cover a new thing. I want us to look at differentiation. Our subtopic today is differentiation. I want us to look at differentiation from the first principle. Differentiation from first principle. Differentiation from first principle. Okay, these are outcomes, learning outcomes. These learning outcomes helps you as a trainer to know specifically what you have to understand at the end of the session. By the end, the trainer should be able to, one, these are the outcomes. You should be able to derive the first principle. Formula. 2, you should also be able to differentiate functions. Differentiate functions using the first principle. Using the first principle formula. Right?
Yes.
Okay. Let us now start on how to. I want us, from our learning outcome, the first one is, I want us to derive this first principle formula. Okay, this is how we go about. Now, the first step, you just draw, this is a Cartesian coordinate, whereby this is our y-axis and this is our x-axis, right?
Yes.
Then from this, you can draw a curve. A curve is not a straight line. This is how you can sketch. That's a sketch of a curve. This is a curve, right? Okay, within this curve, let's say this is point. Let's say this is point A, and this is point B. How we capture that point? We have point A and point B. Normally, when we talk of a coordinate, we write a coordinate in either in x, it is in x and y. This is also, let's assume this is our x1, this should be our y1. If this is our x2, then this should be our y2. This is how we write the coordinates. Are you okay up with this point?
Yes.
This is our curve. We notice two unknown points, point A and point B. And then after this one, I want us to draw a tangent from point B, from point A to B, or from point A to B. This one, this is a tangent. This one, this is our tangent line from A to B. We are driving the first principal formula. Then after this one, you should be aware of this. When this is x, this is y, then this is a coordinate. We write a coordinate. For instance, we have 2, 3. This means this is our x-axis and this is our y-axis, right? This should be x-axis which is x plus a small change in x, comma. This is y plus a small change in y. This is how we write this coordinate. Then after this one, let us find slope. We are finding slope. Slope is just gradient. This is slope or gradient. From basic mathematics, you all know that gradient is, how do you find gradient? Classes, teacher? Gradient?
Change in y or change in x.
Gradient is given by change in y over change in x. Change in y, when we talk of change in y over change in x, we mean y2 minus y1, the difference in y's and the difference in x, and x2 minus x1. We are deriving the first principle formula. Now from this curve we have sketched here, we have change y and change in x. It will be slope or a gradient. It will be y2 minus y1. This is our y2. This is x1, y1. Are you okay?
Yes.
x1, y1. This is x2. This is our y2. We replace here y2 with this. This is y plus change in y minus y1. We say y1 it's y, right?
Yes.
Over change in x, which is x2 minus x1. This is our x2 and this is our x1. X plus small change in x minus our x. Y minus y.
0.
0 will remain with a small change in y over this one will be a small change in x. Now this is our slope. Our slope, we have gotten our slope is a small, we have gotten the small change in y over the small change in x. That's our slope. Now we are still, bear in mind that we are deriving this first principle formula. That's dy over dx, the differentiation. Dy over dx is equals to, I want us to replace this one, change in y over change in x. Small change in y and small change of x. Is there any question? Are we together?
Yes.
Yes. Let's continue. This is our dy dx. This is dy dx and this is the small change in y and small change in x. Don't confuse. It will be f of x plus small change in x minus f of x. The reason of this change of x, it is our y1. Like from here to this point, this is x, and from here to, let's say this one, this is our small change in x. Then all of these are related from this point to this point. It's our y plus small change in y. Right? These are small change in x. Now this is what we call the Leibniz notation. These are Leibniz notation. Then when we introduce the limits, dy dx is equals to limit as the small change in x tends to 0 of the same this one function of x plus small change in x minus f of x over small change in of x. This is what we call the first principle. Are we together?
Yes.
This is our first principle. This is our first principle. We are done with our objective number 1. Let's just look at only one example, know how to use this first principle. Which is more important, let's know that this is our first principle formula. Like for example, you are required to differentiate the following function using the first principle. Number 1, maybe you're given y is equals to 2x. When you are given such a function, you to solve this solution. This is y varying with respect either direct or indirect with x.
Yes.
What you do, you have to increase solution, you increase x. You increase this x. We are finding f of x. To find f of x plus the small change in x, we increase the x. This will be 2 into, we are increasing x, 2 into x plus the small change in x. Then when you are finding your f of x plus small change in x, and then you just replace in the formula. That's dy dx is equals to limit as small change tends to 0 of f of x. What is our f of x? It is here 2x plus 2 small change in x minus f of x. This is our f of x.
2x.
This one, y f of x
Yes.
minus 2x. Are you together?
Yes.
Over the small change in x. Good. We have 2x plus 2 small change in x minus 2x. This is what we do. 2x minus 2x, we get a 0, right?
Yes.
Then it will be limit as small change tends to 0 of 2 small change in x over small change in x. This and this are our answer 2, right?
Yes.
That simple is that. Just master the first principle formula, you just increase the value of x, you replace in the equation, and you find the final answer. You will try this one in your groups. Exercise. Number 1, you try this one, you differentiate. The following using first principle. Using first principle formula. Number A1, y is equals to x squared, and also write this one. Y is equals to 2x power 4 plus 3x. Are we together here?
Yes.
Go try this one in your groups.